So, hello guys, and welcome to today's session, Machine Learning and Overview. So, session is gonna be the second one. Yesterday I have discussed on the machine learning basics on the title Machine Learning Simplest Understanding. Today it will be a continuation of that session. So it will also be a basic session covering the fundamentals. Here in this session, basically I'll be trying to give you an overall idea, an overview, okay? In the chat box, I have given you a link to my blog, which I'll be referencing today for this session, okay? So if you want to see that, you can click on the link and go there. There you will also find the link of the yesterday's blog also, okay? Let me show you. Okay, here it is. Okay, you can see that here too. Okay, so let's begin. Today our topic is basically to discuss these things. We'll be covering some important terms related to machine learning. Before that, I'll be giving you a recap of yesterday's session, okay? Also, I'll be covering some basic tools that you'll be needing in machine learning. I'll be discussing machine learning lifecycle, how the entire process works. Also, I'll be addressing some challenges, okay, in building up models and some techniques that are used. And also some opportunities for future. What can you do in approaching this machine learning world? What can be your career? A bit of career guide also, you can say, a roadmap. Okay, I'll be giving you a simple one. So this is the agenda for today. So like I said, before diving in deep, I'll be giving a recap of the yesterday's session. Okay. So previously yesterday, I have discussed first of all what is machine learning, what is ML, and I said that machine learning is basically a machine is learning to do stuffs, okay, to do stuffs. And there I have discussed that by that mostly we mean three things: predictions, and there's analysis, and in some cases to act on its own. Here I have given some examples related to, predicting house prices, car prices. By analyzing, I have meant that what do you get out of the data by analyzing them. And by acting on its own, I have discussed how machine learning used in robots. You see robots making their decisions on their own. Yeah, that is machine learning. I have discussed all of that previously. Another thing in the recap I want to tell you is that in machine learning, basically we divide it mostly in three parts: supervised, unsupervised, and reinforcement learning. Okay, reinforcement. These three things I have discussed. So it is basically for our prediction, this is for analysis, and this is for like you see decision making. Let me say it like that. I'm not jumping into the whole detail. You can look it up here in this blog. I have given you the link. You can check in the comment section. So yeah, I have discussed these three things basically, and also the applications of basically these three type of machine learning. Okay, okay, fine. So let's start today's discussion. First discussion is tools. What tools are used in machine learning? First of all, language. There are lots of languages are used in machine learning, but mostly Python. There's also R, but we mostly use Python. Why do we use them? There's code editors, etc. But mostly we use Jupyter. There's something called Jupyter. I'm gonna show you that. And another thing is called Colab, Google Colab, a product from Google. Let me show you. Firstly, okay, yeah. This is a Jupyter notebook. Okay, this you call a Jupyter notebook, and I have a model here, simple linear regression. You can see also a Google Colab file. Just type in Google Colab and you will get there, okay? Or you can type in collab.new, this command, and it will automatically open a Colab file. See here, it has opened. Let me write something in Python like our famous command, hello world. Let's print it. It's taking a bit time. Okay. Okay, yeah, hello world. A facility of using this type of files, here you can, at the top corner you can see it is called IPYNB, a specific extension of files. This type of files indicate that you can have this type of feature in your file, that you can have multiple rows. I can create another one and use them separately. Like in this first one I have written hello world. In this one I can like something like hi and print it. It will also work. Okay, we can divide our work in this type of .ipynb files. Okay, clear? Okay, fine. I have shown you Colab and I have shown you Jupyter notebook. Okay, next thing is that, let me go to the our reference for today. I have given you a quick recap. Obviously, you can go to the link here for the yesterday's session and read out what I'm going to tell you today. Like here, you can see that Python programming, code editors, I have mentioned Jupyter Notebook and Google Colab. There's also some other called PyCharm and VS Code. Okay, fine. Now we are going to talk about libraries. Okay, libraries. Okay. What are libraries? You might ask. What is library? Well, libraries are kind of a collection of codes related to a language, which can do specific stuffs. Okay. In the reference, you can see a definition: pre-written code that provides commonly used function. Okay. Okay. Wait. So, by libraries, which ones do we mostly use? I'll show you an example. Before that, let me show you some commonly used libraries. Firstly, NumPy. Just bear with me. This might seem new for you. Another one is Pandas. Okay, these two are mostly used libraries. Everywhere you will see we are using these two libraries. Okay. Why is NumPy used? NumPy is used basically to tackle stuffs that is related to metrics. Have you heard of matrices? Matrices? Yeah? Like in math you have seen A, B, C, D, E, F, right? When we do this type of things, operations, in Python, these all are Python languages, and I'll be only referencing Python language, okay? So all the things that you see here, NumPy, Pandas, okay, all are Python language, Python libraries you can say. When we are dealing with matrices, you can obviously can guess we are doing computations, okay? So when we are computing related to matrices, we use this library. Clear? Okay. Next is Pandas. when we are dealing with something like a data frame, suppose what I mean by data frame, have you seen these type of things? Yeah, where did you see it? In Excel, there might be names, there might be like city, age, and below there's column 1, column 2, column 3, right? You put in the inputs. Yeah, these type of things in pandas are called data frames. It might not be necessarily an Excel file. There's something called CSV file. There's also something called JSON file. Okay, but all of these can be transcribed in this type of uh, table. Okay, for reference I'm gonna say this type of Excel table. Okay, when we are dealing with this type of things, basically overly we use pandas library. Okay, okay, enough talking. Let me show you the library of numpy or pandas. Okay, let me go to the browser. Where is it? Yeah, let me write pandas documentation. You know what is documentation? Documentation is basically a huge written collection of the codes where we can find everything. I mean literally everything that is related to pandas or any library. You can write any library like NumPy documentation. It might be anything documentation. You will find everything that is related to that particular library. It might not be a Python library. Anything you will find it. Here you can see pandas library. Okay, pandas library. You can see the API reference here for convenience, and every command, everything that you can use in pandas are really well structured and here written. Okay, let me enter in something. Let me do, okay, plotting. Under plotting we have so many functions. Okay, there are use cases for that, but I'm just introducing you to these stuffs. Let me write numpy, same thing, numpy documentation, numpy documentation, clicking on it, and you will see that numpy documentation. Okay, you can research a bit, okay, explore a bit. Fine. Okay, let's get back to our discussion. So we have discussed about NumPy and pandas, but these are not the only libraries. There are lots and lots of more, but we are just gonna cover the basic ones. Okay. Okay, next library that I want to introduce to you to is something related to visualization. Visualization, by visualization I'm meaning you see that graph charts, points, 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 points. Yeah, you can create those by using these libraries, or you can you see different type of plots like this plot histogram. So if you want to create this type of things, you will gonna use these libraries, and their names are matplotlib, a bit hard name, matplotlib. There's another one, seaborn, uncommon name if you are a beginner, but these are mostly used. Another one, plotly. You can explore a bit, you can search in the net. Okay, all the documentations are recorded. So matplotlib is our godfather in terms of data visualization. Based on matplotlib, to make it a bit easy, there's seaborn. And if you want to interact with your data, like if I click onto this data point, it will show me the coordinate. It is a comma b. If I go to this, it will show me it is c comma d. If you want to interact with the graph, then you are going to use this plotly library. Clear? Fine. We have discussed about data visualization library, another library. Okay, another one. Let's go. Now, if you want to do deep learning, DL, there's some famous libraries. First one, TensorFlow, TensorFlow. Another one, TensorFlow is by Google. PyTorch, this is most probably by Facebook. And TensorFlow has something really amazing if you want to deep learning called Keras. Keras. Okay, it's a separate library, but it has now, if I'm not wrong, it has combined with TensorFlow. Okay, okay, fine. If you are not getting it, don't worry, you have this uh, reference, my blog for today's session. You anytime go there and read it. Everything I'm gonna say today, in a way you will find it in this reference. Okay, I have mentioned NumPy, I have mentioned pandas, matplotlib, seaborn, plotly. Okay, another one I'm just gonna show you, then you can read it.
Excuse me, is it possible to post the link again? I'm sorry.
Link, I have posted it in the chat box. Okay, I'm posting it again. Okay. uh wait, where is it? Yeah, okay. So I have discussed about, oh yeah, another library that I want to discuss with you is called scikit-learn. Scikit-learn. Okay, why this one is used? All the algorithms you see previously, last session I discussed about regression. I have discussed about classification. Everything that you do, if you think that you have to write codes, well, no. Let me show you. Let me show you. I have opened a Jupyter notebook here somewhere. Yeah, you see this simple linear regression. You know the code for it. This much. Basically, you just need to write up until this one. Then you can do any prediction. For visualization, you just did this extra part. Okay, you see this, importing NumPy, importing Matplotlib, importing pandas. Yeah, you have to do those if you want to use them. Below that, you see scikit-learn, in short form sklearn. You use that for your algorithm, linear regression, whatever the algorithm is. It is really used library. If you want to train anything, you will gonna use scikit-learn. Okay, let me show you the documentation as well. Scikit-learn, okay, API reference. Okay, come on. Yeah, everything that you're gonna use are present here. There are use cases. Okay, okay. So this was the fundamental libraries that you are gonna mostly use as a beginner. Okay, but at first you have to learn these two. Okay, don't get really super excited, you have to learn these two. Not everything, just the basics, and I'm gonna cover these two continuously. Tomorrow gonna be NumPy, and then forward gonna be pandas, then matplotlib, then seaborn, then plotly. All the basics, I'm not gonna dive too deep, just the things that you will be needing. Okay, these things are for intermediate level. Okay, deep learning, you will do it after learning about a bit of uh, machine learning. After learning these things, then you go for theory. If you have a proper grasp on theory, you can learn scikit-learn and implement all your theories. You understand the flow? Yeah,
Excuse
after
me, Bhaiya, where can we find the recordings for all these sessions?
recordings, I'm gonna be uploading in dev community. You are in that community, are you? If
The
you are,
TensorFlow Developers Community, Facebook group.
no, if you are in Tifak Bangladesh, uh, If you are still not, then tomorrow if you attend the session, I'll be giving you the link. Okay, I'll record it now. Then if you join tomorrow, I'll be giving you the link. And I'll be giving the link in those groups as well. Please find it out if you can. Okay.
Thank you
Okay.
very much.
Okay. Yeah. So we are done with our tools. Okay. Let's go to our next agenda. That is machine learning life cycle. That how this model works, how does it go, how does it flow. Again, you have the reference blog of mine, you can see that. Firstly, I have mentioned, let me give you something here. This, suppose this is a machine. What do? We input data, the machine learns, and after learning, obviously you have to put an algorithm there. Okay, after learning, then it gives us prediction, or it analyzes our data, or like robot it makes its own decision, makes decision. This is overall idea. Okay, but how do we code that? I've seen you a code a bit earlier, right? But what's the approach? Is it so simple? What have we done there? Let me show you the life cycle, that what are happening. First of all, you have to collect data. Data collection. Okay, you have to collect data. Okay, you have collected data, but are all data so fresh, usable? Obviously not. In internet nothing is reliable, so you have to clean that data. So another step, it's called data pre-processing. Pre processing. Okay, I have processed my data, my data is perfect, ready to cook. How you are gonna cook it? It's called model training. Model training. Okay, I have trained my model. Okay, I have trained my model. So how I'm gonna check that my model is good or not? Is it accurate? Good. Next step is evaluation. Evaluation. Obviously, you have to evaluate. Okay. Evaluation and another step. I think. Wait. Also evaluation and model selection. When you are using ML models, you are not going to be using one model. Okay, it's your job as an ML engineer to find out which model works the best for your data. Okay, so you're going to be using multiple data methods, algorithms, okay, multiple techniques. Each step I'm showing you has multiple techniques, and you can dive really deep in each and every step. Okay, so there's evaluation and model selection. Fine. Okay, I have picked up the right model for my purpose, the best model that I can. Now what can I do? If I keep it to myself, no, I'm not going to keep it to myself, so I'm going to deploy it. Deployment. Okay. Okay, fine, I have deployed it. I can now use it in my I can download it from Play Store and use it in my mobile phone. Fine. But if I created it once and just left the project, I don't take care of my model. Okay, so if I find a bug and report it to the administrators that there's a bug in your app, in your model, uh, shouldn't it be a matter of concern? Obviously. So there should be someone to monitor. Monitoring part. When you monitor that, after monitoring, you go back that check. Yeah, there's some problem. Where is the problem? Is it the problem, is it in this part, or this part, or is it here, or is it here, or is it here? Where? After monitoring, you find out where is the problem. Okay, and continuously you flow with the cycle continuously. Get it? This is the basic. If you Google ML lifecycle, you might find out lots of other detailed version of machine learning lifecycle, but it's an overview I'm giving. Okay, this is a flow. This is a flow. Okay, let's see our reference, our blog. Wait, I have covered this, covered this. There's are some detailed, okay, some extra stuffs there. It's for your reading. Okay, I have discussed. Okay, let me go to each step, a deep dive. First of all, we are gonna go to data collection. Now you're gonna collect data. You're gonna collect data. But where can you find that? Firstly, you might have that downloaded in your PC, like I have. Okay, I have downloaded. Let me show you one. I think I have collected one. Let me show you. Remember this? This is collab. This is collab. I have, if I'm not wrong, I have already downloaded one. Yeah, salary data.csv. Remember, I have said data can be of in form of multiple things. It can be CSV file, it can be something called data frames, it can be JSON files. Okay, but I've said everything that I've said is going to be a table. You see a 2-column table here. Years experience and salary 2-column table. This is our data. I have that in my PC, just uploaded it. You can have data. Okay, you can download it from internet. Okay, there's a website, come on, work, called Kaggle. Search that, Kaggle. Really amazing website. And if you are gonna compete in machine learning, if you are gonna learn, see lots of blogs, everything, Kaggle is the thing you have to do. Okay, if you want to learn. Kaggle, Kaggle. Okay, fine. I have downloaded my dataset from Kaggle. Secondly, uh, I might have to do scraping, a term called web scraping. What is that? Well, uh, not every website is gonna give you data. That here's my data. Not every count is Dara's gonna give you data. Obviously not. Is Facebook gonna give you data? No. But you can somehow manage it. I'm not going to get in the details. There's you can use HTML. Sorry, you can do some techniques to see all the HTML code written in every website. Okay, suppose this is a website. I clicked on some button, and all the HTML codes of that page. This is a page. Okay, page got in front of me. So what did I do? I coded to pick these type of things from my HTML code and collected them. This type of collection is called web scraping. This type of collection is called web scraping. I think I'm clear. Okay? Okay, fine. Okay, let me delete it. Uh, Come on, got removed. Yeah. Okay. Another thing that you can do is it's not so major. Some website give you data that you can have my data. You can collect it from API. Okay, these are the most used cases of collecting data. Fine. Okay, this is our first case. But if you go to our reference, where is it? I have mentioned in data collection, you'll see something called structured and unstructured. You can see the definition, read it yourself. It's really simple thing. Web scraping APIs, something called challenges. You see, data quality. I've mentioned not all datas are good. Data quality, not all datas are good. Okay, you might need to integrate data. You have data from source A and source B. For your convenience, you might need to combine them. Okay, this is your challenge. Everything won't be in your plate, you have to do some stuffs. And believe me, the first three stages are first two stages I have told you in this in life cycle, that data collection and data pre-processing are the most important part. Okay, the whole life cycle depends on it. If you do these two things, your model is most probably going to be good. Model training is easy, you have lots of tools for that, but for data pre-processing collection, you have to do manual work, you have to understand the data. Most of the works are done here. Okay, fine. Okay, where are we? Quality data, we might need to do integration. There are some tools for your read. Let's go to data pre-processing. Let's go to data pre-processing. Okay, now I have told you that after gathering the data might not be cleaned, you might have to tweak a bit, clean it. Now what might be the problem here? There might be some duplicate values. You know duplicate values. In this table you have a here, also a here, again after some time again a here. This reduces the accuracy of your model, so this is a no for us. We won't count that. Duplicate value is not good for us. There's also, wait, there's missing values. There's in the table you will see that everything is filled up, but some don't have that filled up values in some columns. This might be not filled up, this might be missing, this might be missing. It is also really hampering for our model. uh, Again you can see the reasoning in the reference block. So it is not good for our model. Okay, so we have to delete these things. We have to delete duplicate values, we have to delete missing values. What else? Another thing, it is called normalizing, or scaling might be normalizing. Now I have a data set which value ranges from let's say 5 to 50,000, and in this 80% of the data points are in between 5 to 5,000. Only 10 to 20%, or it might be even less, in the range of let's say 40 to 50,000. Here you have 80%, 80%. Here you have only 20 to 10 to 20%. Okay. Wait. I have told you the wrong thing. Sorry. No. It's fine. Yes. Okay. Let me explain. Sorry. So you have 10 to 20% of the data in this high range. Okay. Suppose this is a data. Everything is here, and some random value is here. Okay. Now my algorithm should have predicted that my probable graph should be this. But for these values over here, it won't predict this red line. Rather, it will predict that my diagram should be this. So is it correct? I'm getting these vague gap areas which shouldn't be in my model. I should have gone with the red line. It's more convenient. For these small values, my whole model is changing from this red line to this line. Okay, galaxy color I'm gonna tell. So it's a problem, obviously you can understand, right? So we have to remove that. And in removing process, what do? let me tell you the process as well in short. You have 5 to 50,000. We can put on some algorithm, some techniques. We can apply it here, and all the values, each and every value will be transformed either from 0 to 1, either from -1 to +1. There's other techniques, but these two are mostly famous. Get it? From 5 to 50,000. Just imagine the power loss here. Power loss of the session, or you can chat it, type it in this chat box. Okay. Okay. Let's come back to the session. It might be power loss. Just imagine 5 to 50,000, and we are just gonna go to 0 to 1 or -1 to +1. If you go to 5 to 50,000, obviously it's gonna be power loss, time loss. Okay, it won't be efficient enough. This is the reason why we convert 5 to 50,000 to 0 to 1 or -1 to +1. Got it? Yeah, let's erase all of this. Okay, let's go up. So in data preprocessing, we might have duplicate values, we might have missing values, we might uh, have to do normalizing. Again, go to our blog. Go to our blog. Normalizing. Okay, yeah. There's other stuff, you can Google it, but these two are main. There's something called categorizing. There might be values which are categorical. You have to deal with those as well. Okay. Next thing you have to do is called feature engineering. Yeah, I have mentioned already as part of feature engineering. Normalizing is a part of feature engineering. Okay. If you don't know what is feature, let me tell you. In this table, A, B, C, you see these three things, column headers. These are called features, each and every one. Features. Got that? Okay. These are features. So when we tweak into this as a whole, it's called feature engineering. Like normalizing. Obviously, you are manipulating the whole column. So it is obviously normalizing. You get my point. Okay, there's other pre-processing features in feature engineering tools, or you can say techniques. There are lots of techniques to address different kind of situations. Fine with that? Yeah. So we have discussed feature engineering. Another thing after feature engineering comes. Now you have, okay, wait. Now you have, like say you have 5 columns or 6 columns. Suppose 1, 2, 3, 4, 5 columns. Okay. How many columns can we visualize? 3, right? 3 dimension. Can we visualize 5? But if we have 5 columns, we have to work with those. So this is a problem. Problem number 1, that we can't visualize it. We can't visualize it. Secondly, uh, all the columns, are these all necessary? It might not be necessary for us. So we have to select those. Like column number 1 and 2 are only necessary. These 3 doesn't actually hamper my uh, hamper my overall model. Okay. Okay. So we have to select our best possible columns. This For this we use different kinds of techniques. Okay, all of these are in the category of feature selection. Basically, we are selecting our features which are mostly relevant to our model. Clear? Fine. Again, let's get to our reference block. I have mentioned some techniques. You can Google them out. It's those things are a bit of the theory part, a bit of deep dive. Okay, I'm just giving you an overview. Next step. Next step is model training. Model training. And for model training, which library we are going to use? Obviously, there's going to be NumPy because there's going to be calculation. There's going to be pandas because every data that we get are related to data frames, data table, etc. And as I previously mentioned, we are going to use algorithms. And where do I find algorithms? In scikit-learn. Also matplotlib. If you want to know the what the data are telling me, then you need to use data visualization, and by data visualization we use matplotlib, seaborn, plotly. Okay, now in model training we use scikit-learn, and for each of uh, the learning methodology, supervised, vised, unsupervised, supervised, or reinforcement learning, there's lots and lots of algorithms. Okay, let me Google it for you. Hopefully we'll find something. Supervised vised algos in ML. Yeah, let me see if I can find any images collection. Yeah, let's open this one. Or I can copy it. Okay, paste it. Come on, work. Hold on a minute. Hold on a minute. Maybe, yeah. Let me zoom in. Here you can see that in supervised there's this type of algorithms. In our supervised, there these type of algorithms. In reinforcement learning, there's this type of algorithms. There are lots of algorithms more. If you want to explore, you can Google them out, and also you can see all the functionalities related to all those algorithms in sklearn API. Okay, I think I'm having a bit of network issue, but still I am giving you what you can do. Okay, and obviously you have the reference blog to check everything that I'm going to discuss today or have discussed. Okay, I think there should be a model select model. Wait. Feature, yeah, see, feature selection. If you want to do feature selection, you can use this type of commands. I can use, like, I want to select from model module. This has these parameters. These are called parameters. Okay, if I go to this, I have installed sklearn model import train test split. It's a module, and from that module, what did I do? I use this train test split like this. See that? And you see in between the brackets the x, y, and test size. Wait, okay, the x, y, and test size and everything, these are called parameters. Okay, you have a function called train test split, and in between that you have all the parameters. If you want to see the reference of each and every commands, you can just even Google it. It will show you direct path to sklearn where to find everything. Okay, fine. This was about model training. Okay, there's lots of algorithms. You just have to do a bit of exploration. Also, as an ML engineer, when you do this type of projects, you have to choose from lots of algorithms. You have to see which gives the best value. And how do you check that? You evaluate. This is our next discussion, that is model evaluation. Okay, for model evaluation, similar to what you have seen in models, selection of models, that supervised, unsupervised. Wait, I have to open my OneNote. Like you have seen that supervised, unsupervised, or reinforcement learning, they have different algorithms. Similar to that, if you want to check the accuracy of the model, you also have different approaches. Okay, for checking those accuracy of those model. Like supervised, you have something called um, R2 score, something called root mean square. I think you have heard this in math class. Yes, it is present here. There's tons of more method for each and every step here, for supervised, unsupervised, and reinforcement learning. Got it? Next. Next, after evaluation, there's model deployment. Okay, how do you deploy? You have to do some of the engineering, that is called software engineering. Okay, for that you use another library, lots of libraries, but in Python you use what? Most famous ones. If you work in computer science, you might have heard Django, but mostly used is Flask because it is easier for us to learn it and use it. We don't need really high works of web development just to deploy it in the web. So Flask is mostly used. So we use Flask to deploy it in the web. As simple as that. Okay. There's some terminologies and other stuffs that you can read it. Okay. These are a bit of discussion related things. So I have just written it for you. So you can check those and explore those later on. Later comes data monitoring and maintenance, also your part of reading. But I'm gonna tell you something, okay? Okay. Very important. I think I have 10 minutes to my session left. Okay. I'm gonna try to cover it. Okay. Let's go to a new thing, that untitled page. Okay. By far, I have discussed collection, pre-processing, pre-processing, then you have training, then you have evaluation. Then what you do, deploy and monitor. These two things kind of just enhances the previous steps. Deployment itself is a huge thing. Have you heard of MLOps, machine learning operations? If you haven't heard of it, search it in the web and you will find lots of things. It is basically related to development, deployment and monitoring. What is my model doing? What should I do? If I search it, if I search it, ML ops, life cycle, you will find a cycle. Okay, you will find a cycle. If it opens, okay, okay. You see this? You see this? A cycle? Yeah, this happens. You use machine learning, you develop the model and deploy it, then the operations takes place. The operators, the administrators all take care of the overall product, okay, to see if there's anything needed, anything plus minus. There might be codes from different people. We have tons of programmers, right? So everyone writes code. You have to check those and install those if those are necessary. Okay, I have given you the term. Your job is to do a bit of research. I'm just giving you an overall idea. After modeling, I have also said something about MLOps. Now, what is MLOps? It's your job to find out. The reference is my blog. Okay? Okay, fine. What else? Another thing, interesting thing. This is something for your interest. Okay? I have told you about MLOps. Now I'm going to tell you about AutoML. This is not related to our machine learning lifecycle. The things that I needed to tell you guys, I have told you. This is extra knowledge. MLOps related to machine learning operations. AutoML, by the name you can say the ML will be automated. How cool is that, right? I don't have to do everything. It is already automated. It is going to be automated. It will reduce my workload. It will improve my speed and everything. This is called AutoML. Okay, search that, research that for yourself. Cool. Another thing in the blog written here, explainable AI. Okay, this is a thing that AI will make decisions like human. This is a research based thing. Got it? Okay, we have learned three new stuffs. More are in the blog, read it. Another thing, yeah, another thing very important. Remember that uh, just model building versus industry level model is not the same thing. When I am building a model, I am building for another thing. Yeah, research is not the same thing. I am doing for my purpose. I have a small interest in machine learning. I have interest in machine learning, so I am learning it. This is my purpose. But industry doesn't see that. In industry, you have to see the efficiency. You have to see how much time am I taking. Okay, is it worth it? My value, is it making me money? You have to check all of those, or else you will be losing millions of dollars. So my aim, focus, goal, all are different. And in research, what do? We research to find what is the best algorithm. Here we don't care about the money, we don't care about what is happening, what's the impact of it. We're going to see how efficient can we make our code. We're going to research on that. You can also find it in my blog, that what are the focus, the goals, the mindset of each cases. Fine. Yeah, so I think I have 5 minutes left. So before that, I'm going to give you a roadmap of learning machine learning, a simple overview. I'm not a complete expert, but by far I can give you a starting. Before giving you that, at the very last, there's amazing resource for you. Those of you are present here, there's amazing resource from Microsoft. Click on the links to explore them. Amazing things. Have you heard of Microsoft Learn Student Ambassador program? Yeah, search that, go to my link, Microsoft Learn. Okay, click on that, go there and explore. There's lots of things all related to quality contents. Okay, I'm just showing you the path. Your job is to explore those. I have given you the link as well. Okay, and finally also you can follow me in LinkedIn. Go there and maybe you can connect as well. Okay, for before the time runs out, I'm gonna give you a roadmap, a simple roadmap. Okay, let's go to a new workplace. Okay, let's go to there. First of all, you'll need to learn a a language, suppose Python. With Python, you need math. Not too much math, but you should be able to understand math and statistics. Statistics and math are the basis of machine learning. All the algorithms are basically math. So I got Python, I got math and statistics. I'm ready to go further. I need to learn fundamental libraries like NumPy. I need to learn pandas. I need to learn matplotlib. Not everything. Again, I'm saying just learn the basics. It will be enough. Search on the YouTube. You'll find enough resources. You can also join my session tomorrow. I'll be covering NumPy. Okay, these three are important. You can also add Seaborn. I have mentioned which are mostly important for you to begin. Then go to learn sklearn by seeing YouTube videos. Okay, go to sklearn and learn about algorithms, how to train models. Up until now, you will see that you are using and making models. You will feel kind of a satisfaction. Okay, up until now. Then this is a huge step. Okay, huge step. Take your time. Take your time. Okay, after that, you might need to learn a bit of Flask for deploying it, a bit of Flask for deploying. Also, obviously, it's a must. GitHub. You can store or do open source program. Okay, contribute everything. Git and GitHub. After that, it is the advanced stuff for ML ops. Okay, you can do ML flow. You can do TFX, TensorFlow extended, in making end-to-end project from data collection to deployment level project. you need ML flow type of things and TFX type of things, but these are mostly used. Okay. Okay. So also for CI/CD, you need to learn Jenkins, something called Jenkins. Okay. There's GitHub Action. GitHub Action. If you can learn up until this part, okay, you will feel another level. If you then learn this part, you will be starting to make end to end projects, literally. Okay, you might get job offers even. This is also a learning must. If you have come this far, you should learn these tools to make your career a jumping. Okay. Okay, this is, after that you can solve it out yourself. In the midway you can solve it out yourself. So I think the time is running out. So please share my blog, share my LinkedIn profile. I'll be uploading the recordings in the dev communities, TFAG also. So, and also if I'll be sharing it tomorrow in the class. Okay, fine, good. Thank you everyone. And yeah, bye. Let's end this. Okay.